Okay. Yeah. Hi, everyone. Welcome to my talk. Topic is Kubernetes with Guardrails, how Mercedes-Benz enables developers across round about 900 Kubernetes clusters. My name is Tjag Rashim. I work as a software engineer at Mercedes-Benz Tech Innovation. I've been working with Kubernetes since round about version 113. I'm not quite sure. I just know the basic year. I'm a very active member of the Kubernetes community, especially locally in Ulm. For example, I'm the initiator or founder, or however you want to call it, of the Kubernetes meetup in Ulm, in our lovely Swabian hometown. And in my free time, I love making music and especially teaching the drums to young children. I work for a company called Mercedes-Benz Tech Innovation, which is a 100% subsidiary of Mercedes-Benz. We've been developing digital products and several services for over 25 years now. About 1,400 employees. Is actually way more nowadays. Yeah, we have several cool business streams. I obviously work in technologies and security, where we provide cloud services and security services for all of Mercedes-Benz. And I work in the Kubernetes team there. So let's jump in. First of all, I want to start with a statement I think all of us can agree. We as developers, we as platform operators, we love Kubernetes for some very good reasons. We all know this stuff, right? Most important one, probably scalability. We can scale all over the world. For my personal taste, the even more important one, portability and standardization. We have standardized formats. We have standardized YAML files where you can deploy workloads in every cluster that we know. And of course, there's more high availability, resource efficiency, automation. We all know that we, and especially developers running on Kubernetes clusters, want to use Kubernetes. So let's take a look at what an application developer sees when he's working with a Kubernetes cluster. So I've just wrote down some very basic concepts most probably know. Like a developer would probably start, I want to run my app, my little stateless app. I'm going to write a deployment. And probably he'll write a service. And probably he'll also write an egress, but that's already getting very complicated. And then he'll maybe not even start thinking about like access control and RBAC and stuff like that. Those are all it gets complicated very quickly. And if you just go run around your cluster as a person who just got a managed Kubernetes cluster provision somewhere, you also very quickly will see confusing stuff, like there's your CSI controllers running, some storage daemons set. There will be your container network interface components running. There's a cloud controller manager. There's all of these components you see and you probably don't really know, or at least don't want to know. And so we have several layers of Kubernetes, of complex stuff, that are actually not really interesting for people who just want to run workloads. And there's even way more for people who want a secure company and who want to secure themselves from attackers. There are several things to consider which go way beyond anything that a developer should have to think about. If you want to run secure workloads, you definitely have to think about if you want to allow stuff like mounting host path volumes. You have to think extensively what kind of network policies you want to apply and how developers should apply the network's policies. And then there's the nitty-gritty, very deep Kubernetes and sometimes even Linux stuff. I guess we're in a room full of Kubernetes experts here, and who has ever really in detail thought about which syscuttles he should be allowing on pod deployments, for example? There's someone raising his hands, very, very good. And there's other stuff, like do we want to have privileged containers running? Do our developers even know, or do application developers even know if their container is running privileged? And also, you can allow in pod specifications specific Linux capabilities. Do we want that? All that together, the important statement is Kubernetes is definitely not secure by default. If you just deploy something like your beginner Kubernetes tutorial, or even some very advanced stuff in Kubernetes, by default, it will not be a secure workload. And the second very important statement from our perspective is developers should develop. So they should not have to care about this stuff. They're very good at what they're doing. They have huge domain knowledge. They have huge knowledge about software architecture. They know how to build reliable systems, but they should be able to use Kubernetes and not think about how Kubernetes works. They want the cool scheduling features, they want the cool auto-scaling abilities, they need all of that, but they don't want to think about the details. Maybe they want to, but they should not have to, especially if you want to ensure that you have secure running workloads in your business, in your company. So the conclusion of that is we need a platform. Obviously, platform engineering is a very hot topic at the moment. We've at Mercedes-Benz have been running a Kubernetes platform for a very long time for Kubernetes, at least in the cloud-native world. And what we build is a fully managed internal Kubernetes platform. At the moment, we're running at around about 1,000 clusters. This changes all the time, continuously, because every developer at all of Mercedes-Benz can, at any time, if they have like the budget, provision or deprovision a cluster anywhere if they want to. We're running in 8 different zones in 2 geo-regions. These geo-regions are quite large. And our clusters are distributed across on-premise data centers or normal data centers and in the public cloud. And so a geo-region for us would be something like Frankfurt, where there are public cloud data centers and our own. Yeah. So let's think about what should a Kubernetes platform for developers do so they can work with Kubernetes without having to thinking about all the complex stuff. Yeah. So we think about that a lot, and I condensed it to these 3 stuff. A Kubernetes platform within a company should definitely enforce security best practices. It should not only hint at it, it should actually make it impossible to deploy some kinds of insecure stuff in Kubernetes, because Kubernetes itself isn't good at that. A second very nice to have feature, which also goes hand in hand with enforcing security, is it should protect developers from costly mistakes. That can be very basic stuff, like maybe accidentally deleting like your CNI wouldn't be that cool, and would probably lead to a lot of weird support requests. But this can also be something like you should probably not be deploying pod disruption budgets that are bad for your application or stuff like that, complex stuff like that. It often also just comes with some Helm chart people want to develop. And a third, from a security perspective, not as important, but from a developer productivity perspective, very important, is it should also enable developers. So they should be, where Kubernetes is too complex, too high mental load for domain development teams, it should enable them to do a lot of stuff that they don't want to think about with a standardized toolkit. So it's also very helpful, so the whole business is running on a standardized platform. Yeah. So let's go through these 3 steps, step by step, and I'll always take a look at how we do it, but I will not 100% focus on that. I'll also always show possibilities how one could do it, because 2 things, we're quite big. We run around 1,000 clusters, and we have some quite huge workloads. So sometimes performance for us is very important, where for most people it would not be. And also, we've been doing this for a long time, so we have some old baggage we're taking with us. So maybe there's more modern solutions that are better fit for your use case. Yeah. So and for security best practices, what should one actually do to enforce security best practices in Kubernetes? There's lots of stuff. I wrote down here the most important, obvious one. You should never allow normal applications to mount host path volumes, for example. That's a very common path to actually exiting the container and to reach privilege escalation in the host US. You should also never allow any application, except it has very good reasons, to run as a root container, to have a root user. Also very common tactic for privilege escalation. And you should also have a selective list of Linux capabilities you allow applications to have. We've had in the past a lot of discussions about that, because there's some networking performance stuff if you have some really high network loads where you have to allow something you don't like and stuff. Yeah, and also obviously you should don't allow host ports, and also in our case probably not allow the usage of public image registries, but private ones. But the last point is something you would have to decide in your threat modeling if you want to do that. But these are things we want to do. There's also a lot more, which I probably forgot. A good starting point, if you want to define like these stuff you want to enforce for yourself, is, for example, the NSA Kubernetes hardening guide, which is a good entry point. But it gets way deeper than that. like we sometimes do debug like the Kubernetes core, what it's doing at some points. I will get to that later on. Anyway, but a good starting point is always the NSA hardening guide, and you will have to decide for your organization what stuff you want to enforce and what not. But these points are a good starting point. But how will you actually be able to enforce such guidelines in your clusters? Well, for that, we actually have to understand what happens when a developer, or you, or anyone, actually sends a request to the Kubernetes API server. The first step that's happening, where I'm going to go into deeper later in this talk, is the authorization and authentication step. There's lots of mechanisms. There's a specific webhook that a lot of people know about. I will go into deeper later on. But right now, the other two parts are more important. So as a first step, there is a mutating admission controller. So webhooks where you can actually mutate the resources that are created. And then there's the last step, the validating admission controllers and policies, if you use very modern Kubernetes, is the step where you can actually, you as a user or admin of a cluster can take a look at what's being deployed, what is it that the user wants to create or change, and decide if you want to allow that or not. So as a first step, if we want to disallow all the stuff I listed in the slide before, we have to take a look at validating and checking what the user is trying actually to deploy. And very, very unintuitive for me, we also have to take a look at mutating to enforce such security best practices. That's just because the Kubernetes core is not only insecure by default, it's actually actively insecure. A very specific example for this, but there are a few more. There's a flag called add no new privileges in the security context of a pod, which defaults to no, there's add no new privileges as a kernel kernel capability, and it actually defaults to false if you have nothing set. So, and it's allow no new privileges false, so it actually allows new privileges by default. So if you set nothing in the pod, this is set to the wrong, like to the opposite of what we want. And so that's something you would have to enforce with mutation, because you don't want users to have to write some pod security spec, pod security context within every pod spec template. Yeah. So how can one actually do admission and mutation? This is a very complex and big topic. There are two very big open source projects you can use for this. There's Open Policy Agent / Gatekeeper, which is like the very enterprisey, very, very powerful tool. You can basically do everything you could imagine with that. It has its whole own programming language for defining policies. It's called Rego, and it's very complex and unintuitive. But Gatekeeper is very high performing, like it's very fast. It has a fancy caching engine for its Rego policies and stuff, and very, very flexible. So if you have very complex use cases and don't mind learning a new programming language, you should probably choose Gatekeeper. Kyverno is the way more like user-friendly version. If you are experienced in writing just Kubernetes manifests and YAMLs, you will very quickly learn how to write even complex policies with Kyverno. Kyverno has some huge drawbacks, though, because it tends to be very slow and it has some very major performance problems. And a few more stuff that is not as nice. It's basically all it has to do with performance. And the third very cool option that we basically use is validating admission policies, which is a core Kubernetes feature since 1.26, I guess, which is a resource where you can actually define policies in a custom language called Cell within the Kubernetes API server itself. Validation admission policies have the huge benefit that they're extremely performant because they're run within the API server itself, so you don't have any HTTP round trip at all. And they're also, like the language Google developed for that stuff, Cell, it's so restricted that it's actually not even Turing complete, so you can't do anything that is not very performant. So yeah. We choose validating admission policies, but there's a lot to discuss on this topic, and actually me and a colleague, Toby, did a whole 30-minute session on KubeCon basically just about this topic. You can check that out on YouTube if you want to go in more detail, but probably for most people, Kyverno or Gatekeeper would be the right choice. Yeah. So cool. Now, if we would have written our cool policies, we would be done with enforcing best practices, right? Well, not really, because how do we secure our security measures? I mean, if you would have some cool policy deployed in your cluster, and your user is able to delete that or edit that, you would only have, like, you would only enable them to run secure workloads, but they could shoot themselves in the foot very easily by deleting that or changing that. And developers tend to do what's necessary to get their application running, and if some policy is blocking stuff, they will just delete it. It will happen. So how do we actually secure the security measures? That's a very good question. And it's very practical. Like, the very nice thing is that goes very hand in hand in how do we actually protect developers from doing costly mistakes. So what we want to do is, ideally, in our case, our users of our clusters, our customers, basically, they're not able to touch anything within Kube's system. System users are locked down. They just get an error message if they try to delete or edit something. But there's also other stuff you want to do. There are several cluster scope resources you would want to prevent access to, something like global clusterable bindings from RBAC, or the webhook configurations that actually enforce that your request to the API server gets forwarded to Gatekeeper or Open Policy Agent or whatever you're using. And yeah, but the important thing, like, you could do a lot of this stuff with basic RBAC in Kubernetes, but you don't want to, you want the users to be able to use the full power of Kubernetes. And if you have very capable developers, they will want to add their own cluster rules. So you can't just deny them everything and only allow them to build a deployment. Luckily, Kubernetes has very powerful features for this kind of stuff. We looked at this before in a very quick manner, but if we look at the first step that's happening within Kubernetes, we see the authentication and authorization step. Authorization is handled by the API server itself, so several means. In our case, it's certificates. But there's a second step, and it's called the authorization webhook configuration. You can actually tell the Kubernetes API server before allowing any requests, so this is way more invasive than basic RBAC, where you can only secure resources from editing or stuff. You can actually intercept any request that users do through the API server with an extra webhook to a custom host. And what the API server will do, if you have that configured, it's a flag on the API server itself, is post a subject access review, it's called. Basically, it's formatted like a Kubernetes resource itself, and it gets posted to this webhook, and you can then decide if I want to allow it explicitly. You can also just say, I don't know, which is the same as denying, but you just give the explicit hint that you don't know it, and you can delegate it to other authorization webhooks, but that's not important. Yeah, so the cool thing is it's basically like a validation webhook, but one step before, and you can implement any custom authorization logic. So no matter how enterprisey cool custom you want to allow your customers to do stuff or not, you can build it in there. We, for example, have the capability to explicitly check if the certificate you're using is from a user from our team, stuff like that. So we can even if security measures we did before fail, we still have this failsafe because that's something we've implemented in there. And as already mentioned, read requests and other stuff can actually be intercepted, which is not possible with usual Kubernetes stuff like RBAC, which is always just scoped to a resource if you want to change it. Yeah, and how do you implement that? There are several ways. The most common one is probably a fully custom controller, which is, it doesn't matter which stack you're developing, it's not that hard. It's an HTTP request, which you have to answer to. So, and in our case, we actually have a static open policy agent running on each node. Why is it static? It actually has to, the API server wants to start up, and it has to be there as a flag. So you cannot run an authorization webhook within the same cluster, like deployed to the API server, because the API server would have to already be started if you want to deploy the node. So you have to actually be running it, in our case, as a static pod on the controller, on the node itself. A very common solution, like I know this from like the hyperscalers and stuff, would actually be to have an external service somewhere running that does this, but you will have to think about latency doing that stuff. We have an open policy agent running statically on every node doing complex Regal stuff and authorizing that, but I would not say this is the best solution. That's one of the cases where we've been doing this for a long time. It's been grown. Maybe nowadays we'd do it differently. Yeah. Okay, cool. So if you would have your custom authorization implemented within your authorization webhook, then we've got these two covered, right? I mean, that's way more easily said than done, but I guess we have the concepts covered to do this. one has to do a lot of work, obviously, to implement them. And then there's still missing the enabling part. And that has just gotten, when you've implemented such restrictive security and measures and stuff, way more important. Because, for example, several Helm charts just have some random Docker Hub image in them, which is fine. Developers want to use that stuff. But we actually block on a network level any registry except their own internal ones. So almost every Helm chart you want to deploy cool from the internet from some tutorial will not work. For that reason, we have stuff, we call it the EMU webhook. The name means nothing, it's just a weird internal joke. It is, yeah. Which does nothing else, it's a mutating webhook, but automatically exchanges if it detects, oh, this is an image without any registry in front of it. And sets that automatically to our own secret registry. Hint, our secret registry is not running under our secret registry.mercedes-benz.com. Yeah, but it also automatically replaces that, for example, if there's something available in our cache. That's something we do. Another thing is there's actually some quite valid use cases where you want to run workloads with very high privileges. The very common one is something like service meshes. A lot of people want to do that, especially people running huge workloads, which we do have. Another very typical use case for that would be observability tooling. You want to run an Elastic agent. I think some people from Elastic are actually here, probably. No? You want to run a Datadog agent or want to do stuff like that. And obviously, we do not want to deny this stuff for the developers. And we probably will never be able, across so many teams, to fully standardize that stuff. So what we do is actually we have an add-ons controller. So in our clusters, you can, as a consumer of this cluster, a development team, there's several CRDs available for you which you can deploy and where you can set in the CRD only exactly those config values that we allow. So we can keep our need to know and our policy intact. And our controller will deploy the more privileged stuff needed. For example, you can see on the right side the Datadog CRD. You can configure your cluster name and some tags that do something in Datadog. I don't know that stuff. The important thing is we have a controller running, so you can deploy that as a normal customer, and our controller will deploy the images in the back that have privilege, so it's still within the management team. We have to approve stuff like that, and we can actually enforce, like, if we know that tools have insecure configurations, we just don't provide them to our users. And so that's a pattern we have for several stuff. These are the two most obvious why you would need more privileged containers to do them. We have several more for this. And so if a customer wants to do something that is privileged, we'll wait and check if there's lots of people who want to do that with the Mercedes. And if there are, we will just extend our own controller, which is a basic operator just deploying YAMLs. It's actually a bit generic, so we're capable by only deploying a few CRDs, a few YAMLs that we can deploy additional add-ons. Yeah, so that's actually already my talk. I'm quite good in time. We will have 5 minutes for question and answering. I hope I gave you a quick overview on how you can, or what steps you have to think about and which directions you can go if you want to run a very secure platform for your developers. And as a last hint, we are hiring. We're actually still hiring specifically for the team I am working on, and my colleagues who are here as well are working in. So if you're interested, you can scan that QR code, and maybe we'll be colleagues soon. And yeah, any questions?
How many people implement and maintain this as developers and provide operations on it?
Around about like 20, I think 23 or something. Yeah. So it's economics of scale. Yeah.
Hi, how are you handling the mutating stuff with like GitOps? If you're mutating on the fly resources, is that somehow fed back into your GitOps pipelines, or do you do GitOps?
That's something you would have to ask the users of our customers, the users of our clusters. Basically, we don't, like, you probably mean this one, right?
Yes.
The image mutating, yeah. If you're that good, I tell it, of a user of clusters, you will just know that you have to use our own registries, and that will be in your manifest within GitOps. And there's other stuff we always mutate, the stuff I talked about here. But that stuff, no GitOps tool will automatically try to reconcile because it's set to default values deep within, like in the security context of your pod, which is stuff most people never configure on themselves. So it's just set to a different value, and most GitOps tool will not care about that.
Okay, thanks.
So if you don't use GitOps, how do you instantiate the clusters? So how do the development teams get a cluster and spin it up, and how is it all preset and configured?
So internally, we use Cluster API with a management cluster in each region. That's also something we did a talk once, but it's a few years gone by Sean, who's actually sitting in front of you. So we manage them with Cluster API, and our customers can actually provision the clusters themselves within a web GUI, for example. So they don't have to do a pull request, and there's an API available as well, so they can automate that if they want for their repositories. So we basically have a full internal development platform. So they don't have to do a pull request to create a cluster, they can do that fully on their own.
Hey, hi, thanks for the talk. I was curious about how do you manage the add-on installations in the clusters before they become ready to serve customer applications?
Do you mean the add-ons I talked about here? Or do you mean more general add-ons like the CNI and stuff?
I'm not sure if you're referring to the Kubernetes SIG add-ons controller here, or is this a custom controller?
No,
that you
no, I'm not. We actually have, there's actually two types of add-ons. I can't go into too much detail, but this stuff is actually running, there's a controller running in each cluster, which is completely self-developed, which is an operator for the CRDs we provide. So with each cluster you provision from us, there's already a CRD defined for Istio, for Datadog, stuff like that. And that's a completely custom developed operator by us. It's with KubeBuilder in Golang.
So just to expand on that, so in that CRD type, you would have multiple add-ons which you have specified, and then that's what you sort of reconcile on?
No, you would deploy. If you're a consumer of our cluster, you would deploy, and you want to use Istio, for example, you would just deploy one Istio CNI CR.
Correct. So, okay.
And if you would want to use Elastic as well, you would deploy the Elastic CR. And our controller, like, you can only deploy it once per cluster. We enforce that.
Thanks.
Yeah, hi. Thanks for your talk. Would you also rewrite your emo webhook with a policy controller now as well? So for changing the image registry, or would it have too much impact on your side?
This one?
Yeah.
This one is actually, the confusing thing is the emo webhook itself is optional. So the emo webhook itself is add-on like this. You would probably not be able to write it with common policy stuff like Kubernetes or Open Policy Agent, because there's a lot of custom logic that goes into deciding, is this thing in our registry, is it mirrored or not?
You have also background logic to check if the image, you will only change, you will mutate your object only if the image also exists.
Right, and otherwise it will print a warning.
Ah, okay, yeah. It's not like a simple
it's if you can replace, yeah, so there's basically caching stuff which with scanning of images, like which is allowed from public registers and which not, which comes from a registry, and it checks that.
Oh, okay, cool. Thanks.
Thank you for your talk. I wanted to ask you, how long did it take to get all those security measures figured out and implemented, and then, made it available to everybody?
Figured out is a part I can probably not answer, because we've been doing this, I don't know, since 2015, I think this platform has been running, so very early on in Kubernetes. But implementing it is actually quite surprisingly fast. We had to re-implement it completely last year, because we were moving from Kubernetes 124, where PSPs were removed, and this used to be we used to rely very heavily on pod security policies. And implementing all the policies new with our fancy validating emission policy solution took about like 3 to 4 weeks. But we did a lot of circling. So if you would decide early on which way you want to go, you could probably do this a bit quicker, maybe. Well, depends on how complex your policies are. And we actually had to experiment a lot because not a lot of people are doing as many policy decisions as we are. And so that's why we had to experiment a lot. Yeah, there's actually, as mentioned, we go in very deep detail in our KubeCon talk about that.
I have another question, if you have the time. How long would it take for you to switch from the Ingress API to the new Gateway API?
I mean, probably not, for us, not that long, because we just run our own stuff. For our customers, we can't enforce that. We will enable them to do it. We will allow for them to do it, but we will not, at least it's not planned. But for us, it would be a quick thing. But what do we expose, like the Kubernetes API server? It's not more than that. Yeah.
Thank you.
Oh, we're out of time, I'm sorry. But I'm here. You can ask me in person. Or us. Sean is here as well. Thank you.